Hey, it's Dr. DeBord, and today we're going to talk about states of consciousness and sleep. So, the first question for you to consider is what actually is consciousness? If a person in a coma, is that a different state of consciousness? When you think about sleep, obviously there's some level of consciousness, but it's a different form because you can be drawn into full awareness from a totally like hypnotic, like dreamlike state. Hypnotized is another form of consciousness. Drugs alter consciousness in a number of different ways, including coffee and nicotine, are ways of changing the way our conscious experience of our perceived reality is. Dissociation is a weird thing if you've never heard of it before, but in its simplest form, it's just spacing out. It's a form of not being in the here and now or connected with the moment. So some would argue that most of life is spent that way, and only through something like meditation can a person become fully aware of the moment. But in its extreme form, dissociation is just really splitting off one's experience of the here and now into different fragments of personality. So actually they call multiple personality disorder dissociated identity at this point, because it's such a fragmentation away from the current moment. There are times when people have post-traumatic stress disorder where they'll have a flashback and they'll be like living back in that moment. As a therapist, one of the things that I've had to do before is draw a person back into this conscious moment by asking them to focus on their five major senses. Like, what do you see in this room? What are five colors you can name? Can you feel the chair on your butt and the back of it on your back? And what do they smell? I mean, just draw them into their five senses to keep them from dissociating. Meditation, I already mentioned, kind of is a form of consciousness. Hyper-awareness, I wonder if you've ever felt that kind of experience where suddenly you are like very aware of just everything coming into your five senses at one moment in time. And then again, distraction is another thing. So these are just some questions to think about in terms of consciousness. One thing that happens is that we're often not really paying attention to the here and now. We do have selective attention. Most people think that they are good at multitasking. The research shows that none of us are, even when we claim to be. We're not, because we only have we have a limited amount of attention we can focus on any one thing in our awareness. A lot of times we're in our head and we're not in the moment. This experiment that I have pictures of down here basically shows a study where a person walks up to another person on campus and on a university campus and asks for directions somewhere. In the middle of their conversation, some construction workers appear to like cut between them. And while they're doing so, they're carrying this big giant board, board. And what they do is they switch the person that the direction giver was talking to. The question was, how many people who were giving directions even noticed that the person they were giving directions to changed? And the answer to that question, this study has been done over and over again, most people don't even notice. Typically, it's about 75% of the people don't notice, 3/4. Because a lot of times, even when we're interacting with one another, we are in our heads and not in the current moment. Okay, so I'm going to switch gears to talk about sleep as a form of kind of altered consciousness. It's weird, we spend so much time in sleep, but it's actually something that psychologists don't know nearly as much about as much as we'd like to know, actually. We have natural biological rhythms that occur in our bodies as humans. Circadian rhythms are bodily rhythms that change predictably within a 24-hour period. So circa means around, like when we talk about circus, so that's, 3-ring circus around, and dia, like in Spanish, is day. So circa dia is around a day or about a day. And some of these things that we have in our body, well, it's like temperature. I have here in this graph, you can see that typically what happens when you look at our body temperature, that it gets like at its lowest, typically, if you have a typical sleep pattern, around 4 a.m. in the morning. And then during the day, it goes up, but we can predict that on a 24-hour cycle, we'll typically, in our deepest sleep, have low body temperature. And as we start moving around during the day, our body temperature returns back to its normal state. Another circadian rhythm we have is a release of hormones into our body. This is a picture, we just talked about chapter 3 in terms of the brain. We have, as you can see here, in our eyes, this optic nerve that goes back, and I'm using the cursor to point to the picture. And then we have attached to that optic nerve something called the suprachiasmatic nucleus, which is a mouthful. And it has light-sensitive cells. So typically what happens if you have a normal sleep pattern, as the sun starts to go down, these light-sensitive cells in the suprachiasmatic nucleus will recognize, oh, it's starting to get dark, and tell the pineal gland back here to release a hormone called melatonin. Some of you may have heard of this, even you can buy synthetic form of it in Walgreens or someplace like that. And it makes us drowsy. That hormone makes us sleepy. So the suprachiasmatic nucleus tells the pineal gland, release melatonin. It releases melatonin, we get drowsy, we sleep. Then as the sun starts to come up and your bedroom becomes light, again, the light detecting cells in the suprachiasmatic nucleus will say, shut down melatonin production and release, and it does, and we become awake. So melatonin is another circadian rhythm, and you can see basically when our body temperature is the lowest is when melatonin release is at its highest. So these things kind of work in tandem with one another. Okay, another thing that happens, and this is strange because there's also there's a little bit of a difference between adolescence and or young adulthood versus the rest of adulthood. But typically, once a person reaches full adulthood, and I would actually typically say maybe more in their 30s, you will become more aware whether your kind of genetic makeup leads you to be a morning person or an evening person. Typically, adolescents are evening people. They stay up late and they want to sleep late in the day. That has a lot to do with what's going on with hormones. But when it comes to once kind of brain formation and myelinization is complete, typically what happens is you can start to recognize patterns in people. When are people most productive, most alert, most aware? And you can divide it up roughly into 2 types. And these are called chronotypes. Chrono is time types. Some people are more morning types and more productive then. Others are more evening types. And there are some differences. I will post a video on our Canvas page that briefly describes some of this for you. The question for many people, I typically ask this in class, how much sleep do you get per night? One of the things I've found is that most people are not getting enough sleep because they're working. They have maybe even 2 jobs. They have 4 or 5 classes. Some people have other responsibilities in band or something like that, and not getting enough. Typically what we need is between 7 and 9 hours of sleep per night in order to fully function. If you have insomnia that gets in the way, and there's a lot of recommendations you can look up on the internet about what to do if you have bouts of time when you can't sleep and you have insomnia. This can be pretty frustrating for many people. Some of the tips for dealing with insomnia, some people don't know this, but like your phone, here it is, emits like a blue light, and that stimulates those cells in the suprachiasmatic nucleus. So if you're staring at that blue light, at 2 a.m., that's telling your brain, don't release melatonin and stay awake. So most phones and iPads and devices like that have blue light filters. So it's like, and you can just switch that to block that so you won't interfere with your sleep. Also, just staying up, talking to your friends at 2 o'clock in the morning is going to keep you awake, especially if there's drama. 2, use only your bed for 2 activities, and that would be sleeping, and I guess you can figure out the other one. Exercise, but don't do that late at night. You need to really get your body. There's been a lot of research to show the more a person exercises during the day, or if they engage in at least heavy exercise at least once a day, they'll spend more time in deep sleep. Avoid caffeine, alcohol, nicotine and caffeine are stimulants. Alcohol actually can make a person drowsy at first, but then disrupt sleep later on. Use a sleep schedule that's consistent. Keep things dark, quiet. If you know what works for you, if you use a fan, you do that. Don't take naps during the day if you're having insomnia, because that'll interfere with the sleep that you get. If you look at this chart here, this basically shows over time how much time we spend in sleep. And you can see that infants spend a huge amount of time in sleep, up to 16 hours, and they're dreaming a lot. The question is, what do they have to dream about? It's a good question. But as we get older, we spend less time in both dream sleep and also non-dream sleep. Why do we sleep then? Some say it's evolution, that we as humans can't see well at night, and the ancestors of ours who basically laid low at night and weren't out running around didn't get picked off by nighttime predators. So they could pass their genes on to future generations, and if we inherited that because they survived and the other people didn't, that's one explanation for why we sleep like we do as humans. Another one is to keep our synapses alive. We just talked about this in chapter 3. Well, especially dreaming. If you looked at that chart I just showed you, the infants dream a lot. A lot of it's thought to be to keep those neurons active, and so that we can have those available as useful tools in making sense of our reality later on. There is a lot of research showing that sleep enhances memory and the learning, both physical and other sorts of memory. So the best thing you do if you study for a test is to sleep right afterwards. During deep sleep, we release growth hormones that allow repair of the body. And so that's another important thing that happens. Here are the stages of sleep. Usually it happens with a 90-minute cycle. These are just identified stages that correspond with brain waves that are happening as we sleep. But we have the lightest stage of sleep being stage 1. Then we go into stage 2, which is a little deeper, stage 3. Stage 4 is the deepest stage of sleep. And that is when repair of the body occurs. People who spend more time in that are better off in terms of like body repair, and also they're less depressed. So actually, if you can exercise, force yourself in stage 4 sleep, a person is typically less depressed. So you go 1, 2, 3, 4, and then 3, 2, and then you hit REM sleep. And REM sleep is rapid eye movement. Rapid eye movement, if you see someone sleeping, you know them well enough, and you see that their eyeballs are going back and forth underneath their eyelids, and you wake them up, they'll awake and report a vivid dream, because rapid eye movement sleep is when dream sleep occurs. And as you can see, as the night goes on, we spend less time in stage 4 sleep, the deep sleep, and more time in dream sleep. And that is all I have for this section. In the next section, we'll talk about dreams, and also we'll talk about drugs. So I will see you in the next video.